أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. I welcome you all in the online lab session of electronic devices and circuit. Hope you all are fine and having good health. Hopefully my voice is clear to you and screen share as well with you. There is some kind of issue in Zoom meeting control. But anyhow, we are start this session. Okay, let's start the lab 10. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. MOS differential amplifier. Now, this is the objective of today's lab of differential amplifier by the metal oxide semiconductor, the differential pair. To implement the metal oxide semiconductor differential pair circuit of two methods to match devices loaded with resistive load to measure common mode gain, differential gain, and mod common mode rejection ratio, that's CMRR, of the given circuit. After 1 minute of Azan break, we again continue today's session. So please wait till 1 minute. Okay, we again start the session after 1 minute of Azan break. So I'm sharing my screen. Comes to the differential amplifier. This is the MOSFET ways differential amplifier theory, that is introduction. Come to the introduction that MOSFET is by far most widely used transistor. If the differential amplifier, differential MOSFET amplifier is a wide variety of amplifier that we are using. Similarly with the MOSFET transistor, the differential amplifier can be made by BJT and also by the MOSFET. So here we make a circuit of differential amplifier by the MOSFET, and it is the backbone of modern electronics. Differential amplifier is a backbone of modern electronics. Differential amplifiers circuit can also be made in opamp. That means the operational amplifier. Operational amplifier can also be used to make a differential amplifier circuit, and it is also used in the moderate circuits, modern electronics. One of the most common uses of MOSFET in analog circuit is construction of differential amplifiers, that we have to make a differential amplifier. How to make a differential amplifier? We can uh, discuss this in this figure. But before that, we have to discuss the theory. So, one of the most common use of MOSFET in analog circuit is construction of differential amplifiers. The latter are used as important stage in opamps that I already incorporate the same scenario, video amplifiers, high-speed comparators, and many other analog-based circuits. MOSFET differential amplifiers are used in integrated circuits. Integrated circuit means that in ICs, that in op-amp, these are the integrated circuit of differential amplifiers. Such as operational amplifiers, they provide a high input impedance for the input terminals. If we talk about the uh, operational amplifier that we call in short op-amp have the capability have high input impedance and have low input impedance. If anyone have idea that why we use high impedance in op-amp input side and why we use output low impedance at the op-amp, can anyone can tell me why is the input impedance of op-amp is high and output impedance of op-amp is low? Can anyone tell me this question? Anyone can tell me? Okay, I'm telling you. The main aspect of this high impedance in op-amp is to match the compatibility of input source by the supply of AC to the op-amp. We need to get the high impedance of op-amp, and to connect the load to the op-amp, we need to get the output impedance of op-amp at the lower side. So that's the reason op-amp have high impedance at input side and op-amp have low impedance at the output side for the compatibility issues, and to connect the input towards the input side high impedance and connect the load side to the output of the op-amp. For this reason, the output impedance is lower of op-amp. So these are the two reasons why we got the op-amp impedance is high and why at low from the output and input respectively. The general topology of differential amplifier is shown below. Two active devices are connected to a positive voltage supply via passive series elements. That two active source of elements are connected with the MOSFETs Q1 and VG2 with Q2. These devices are connected at this level, that input active source VG1 to Q1 and active VG2 supply to Q2. Passive series elements. Series elements. Passive elements are those which consume electricity. They are not restore energy and can provide. So passive elements are those elements, devices which can only consume electricity. They cannot store or save electricity by in their internal device. So those devices which store electricity themselves, they are called passive elements, and active are the opposite to them. Comes to that passive series elements, the transistors must be match pair to match MOSFETs of two match BJTs. Similar circuit can be made by BJT, but here we are making the circuit with MOSFET. Most of the circuits that we are making by BJT are in ECD class and ECD lab, but the ADC lab and codes are moreover discussed with the MOSFET devices. They are not on the BJT base. That's the reason most of our devices are based on MOSFET based circuits. The pull-up loads are similarly matched to each other. The lower terminal of the active device are connected together, and a DC current source pulls current down towards the negative voltage source For proper biasing, the controlling input ports of the devices are connected to the input signals. The same circuit that you can observe here, that supplies are connected at this level of gate side of the MOSFETs, and these are the output side of voltage can be measured at this level, and this is the negative biasing circuit which is providing at here. The controlling of the input ports of the devices are connected to the input signals. Same circuit can be made uh, in simulation of multisim. Now comes to the working, that how it works. MOSFET and BJT have different amplification principles. MOSFET can work on different principle of operation of application, and BJT can work different amplification operation of the principles. However, their output and transfer characteristics are similar. Their transfer characteristics, that means their saturation region is common, but the working is different. But the saturation, cutoff, active region, this is the same thing in BJT and MOSFET. Either the difference of ohmic region that is not in BJT, or with the same different name of in BJT. Okay. Anyone have any kind of query till now? Please feel free to discuss. I will repeat and to call for you. Anyone have any kind of query? We have Mr. Chakar Khan, Muhammad Raza, Muhammad Aman Maksud, and Shah Faisal. If anyone have no kind of query, then we continue our session again. Indeed, the MOSFET output current saturates output over a wide range of drain to source voltages. The enhancement mod, this is the two mod of MOSFET that how many mods of MOSFET can anyone tell me? One is enhance, and what is the another mod of MOSFET? Can anyone tell me what is the another mod of MOSFET? One is enhancement mod, and second is what? Okay, one is enhancement mod, and second is depletion mod. We already discussed these things in our theory as well, and most of the time we already discuss these kind of topic, because these are the minor kind of topic you all know, and you better know about these things because these are the basic things. There are two modes on which the MOSFET is work, that is enhanced MOSFET and depletion MOSFET. So here we are going to implement enhanced MOSFET of MOSFETs in our lab have a typical threshold voltage. Enhanced MOSFET the typical threshold voltage is VT, threshold voltage, that is 3 volt. What is the meaning of threshold voltage? Can anyone tell me? Threshold voltage is the kind of voltage by which uh, after got these kind of voltages, the MOSFET can start working or conduct. Can anyone have a kind of question? Please feel free to ask. Mr. Chakar, your mic is on, so I thought you have question. So, in contrast of BJTs, MOSFET have negligible DC input current, so that the MOSFET DC current gain can be on the order of millions. The current of DC would be said the gain, sorry, current gain would be in millions. A small AC input current exists due to the charging and discharging the device input capacitance. Capacitance can be discharged and charged. The kind of things can be impact on the current gain by the impact of capacitance. Capacitance is have the capability to charge and discharge and restore energy multiple times in the second of spike. The ability to control the drain saturation current with the gate source voltage is described by the transconductance, that is GM. I already incorporated the topic. The transconductance, it's a ratio of our drain saturation current with the differential drain saturation current over the differential VGS voltage ratio is called the transconductance value. VGS should be greater than to the threshold voltage. Threshold voltage is what? Threshold voltage is a kind of level by which the MOSFET start conduction working. After that means when MOSFET got 3 volt, now it will start working after these volt. If you provide 3 volt less than to that, the MOSFET cannot work from its active region, from its saturation region, and it cannot extract or provide the current from the input source. This is the main thing we all know because it's a main and minute kind of topic. We all know about this thing. Operation with the common mode and differential input voltage comes to that when both signals are equal. Both signal means there are two types of supplies which are incorporated here. When both signals are same means here is 5 volt and here is 5 volt. If 2 volts of levels are same, this is the thing which it called when two signals are equal. That means the magnitude of both the sources, that VG1 and VG2, are equal. The input voltage are equal since both transistors conduct same current. That means the one current and another source of current are same because their voltages are same. As a result, difference between the output input signal is zero. And obviously, it's a basic thing. There is no difference in the current. The differential amplifier cannot provide the difference kind of current because both the current, both the voltages are same. There is no cancel out effect. Remaining current can be zero. Just like input signal, when one of the signal rises higher than the other, it streams more current through the transistor connected to it, and the current through the transistor, other transistor. Therefore, difference in the other voltages increase in figure 9-1. That is already we discussed here in figure 9-1. Shows current flow through Q1 and Q2 as we apply differential signal at the input. And how can we find the differential gain? It's a simple formula. The MOSFET differential pair with a differential input signal VG1 and VG2 applied, the gain will be, the differential gain would be DA means differential gain. Gain represented by capital A. VD2 minus VD1, this is the differential source voltage 2 minus source voltage 1 divided by input differential voltage, provide the result in the form of GM transconductance multiplied by the drain resistance. Both the multiplied product can be provide the drain, the differential gain of the amplifier, and by this formula we can also get the differential gain of the amplifier. Up till now, any kind of query if you have in your mind, please keep it to us. I will answer your kind of questions. Otherwise, we continue the session. Common mode voltage gain, and what is it? Due to finite current source impedance, that is RSS, transistor mismatch and load mismatch, differential amplifier would have finite common mode voltage gain considering only finite current source. Output impedance, that is output resistance R0, common mode voltage gain is as follows. How can we get the common mode? In differential mode, we can get the common mode by the same thing, that we provide the same supply from the VG1 and VG2, and there is a common mode can perform. That means there is a no voltage difference or current difference. But the differential mode can be work if we provide the supply from one source but another source is off. So there is a difference between the voltages from source 1 and source 2. And similar can be thing vice versa if we stop or less than the voltage of V1 and the V2 voltages is greater than to that. So there is a difference between these two supplies of voltages, and current can also be formed in the different way. So this is the main thing, that by the comparator, by the differential way, we got the uh, differential mode from this thing. Now, but we are discussing here common mode. Okay. Considering only finite current source, output impedance R naught, common mode voltage gain is as follows. That is common mode gain. Common mode gain, how can we find? VD1, that is differential source voltage 2 minus differential source voltage 1 divided by common mode voltages. Common mode means both the voltages are same because both the supplies are same. So this the difference or ratio is called the common mode gain. Similarly, if we have the drain resistance divided by the 2 times of the source resistance, that particular ratio can also be provide the common mode gain. Up till now, any person can have any kind of issue. Please feel free to ask. I will answer your questions. Common mode rejection ratio. Now comes to that. The common mode rejection ratio is a measure of how well the device rejects a common mode signal. Common mode that is called CMRR, common mode rejection ratio, and it is what that how well the device rejects the common mode signal. Common mode signal is what both the inputs have the same kind of supplies in form of current or voltage when you provide it to the amplifier, both the supplies are same, and this is the common mode rejection ratio that reject the common mode signal. So how can we find it? The differential gain over common mode gain. The difference or the ratio of these two things we can got the common mode rejection ratio. Okay, comes to that how can it be converted into decibel? When we got the result in this ratio, first we have to get its mod. What is the meaning of mod? If we got the ratio in negative sign after passing through from this modulus sign, we got the positive result and take the log of that positive result multiplied by the value of 20 and we got common mode reaction ratio in decibel. So this is the way that how we can find the common mode reaction ratio in this way. Okay. Mode of operation on which the differential amplifier can work and there are three modes of operation for differential amplifier which it works. Single-ended mode. What is the meaning of single-ended mode? Single-ended mode means a differential amplifier is operating in a single-ended mode when an active signal is applied to only one input and inactively connected normally to ground. That means the other supply is ground. That means one supply is active and another supply is ground. The supply is not connected here. This is the single mode. Similarly, if we provide the VG2 supply towards the differential amplifier circuit, this supply can be ground. This is the same scenario that is implemented in the form of single mode. Now comes to the second mode, that is differential mode. Differential mode is what? For differential operation, two active signals are applied. That means both the supplied signals are provided to the differential amplifier. Applied to the differential amplifier, the output magnitude and polarity will reflect the relationship between the two inputs. What is the meaning of this thing? Differential amplifier can be happened by two things. That we supply, we provide the supply from VG1 and VG2. Both the supplies have level of voltages can be up and down. Both the supplies cannot be same in magnitude and both the supplies can be provided with the difference of amplitude but with the opposite in sign. This is the main thing that we got the differential mode in differential amplifier. This is the second way. Comes to the third, that is common mode. This operation occurs when two signals of the same amplitude, frequency and phase, both the supplies are same. Applied to the differential amplifier. In this mode, the output of the amplifier is ideally zero. The output of amplifier is ideally zero because all the supplies, all means two supplies which providing it to the differential amplifier have the same amplitude, means same voltage, same frequency if we applied in the AC signal and same phase. That means all the things are same. If the things, all the parameters are same, so there is no difference. So this thing would be differential amplifier mode would be called common mode. In this mode, the output of amplifier is ideally zero. Output we got it zero because there is no difference between the supplies in amplitude, frequency, and phase. So we got the zero amplifier output. When measured between two outputs, if we measure the output, it would be zero because both the effect can be cancelled out to each other. Procedure that how it can be formed. Construction the circuit that's 9-1 use RD1 and RD2 equal to 47 kilo ohm and RS that is the source resistance that is 100 kilo ohm. Turn on the DC power supply and set the positive supply to 10 volts and negative supply to minus 10 volts. And where can we implement the negative supply? Negative supply can be implemented at this level that is VSS, common source voltages from this side. This is the negative 10 voltages and the supplied voltages are VDD, common drain voltages are drain to drain voltages are 10 volts similarly but in positive. VDD are positive 10 volts and VSS minus 10 volts. Okay. So up till now, if anyone have any kind of query, please feel free to discuss. Otherwise, I will continue the session in same way. Make sure the transistor are properly matched and drain resistor RD are equal to each other. After the transistor are loaded, make sure that they are in saturation region of operation when finding the differential gain. Note down the readings given in table 9-2 that is here. Differential gain, calculate CMRR. And how can we find the CMRR? CMRR can be found the differential gain over the common mode gain. Both the difference of ratio, we got the common mode rejection ratio. And apply the same input signal through the function generator and attach the separate sheet of calculation. Calculation can be done in the sideways, but if you not have any kind of space, you can write it in the separate sheet. Comes to the observation column that how it can be filled. So VD1, these are the supplied drain difference of voltage of source 1. You can be put it here and here VD2, you can put it here single ended, that is the ratio between these two things, you can got the differential gain at single ended. What is the meaning of single ended? Single ended means only one supply can be active at one time, another supply is off. That means if this supply is on, this would be off, and this supply is on, that would be on. And if both the supplies are 1 1 or the same thing, so gain can be got by the respective reading, and the same thing can be implemented at this level. Okay, VG1 supplied voltage can be provided to you in 1 volt, 3 volt, 1.5 volt, 0.5 volt. Similar in this category, you can use these things and implement the same scenarios and fill the observation table. Up till now, we discussed these three columns, and at the end, what the differential thing? Differential reading can be found, differential gain by this formula. VD2 minus VD1 divided by V input gain. After this difference, you got the difference gain. That's the way that how you can find the difference of gain. Differential gain you can put at this level, that this minus this and divide by VD1. You can got the differential. And same scenario can be reading can be filled by this column, the fourth one. Okay. The thing can be happened by the multi-sim simulation. Simulation you can also make. I am making at this level, but you can also make by yourself. These are the transistors that IRF 540NS and IRF 540NS. These are the two transistors by which the circuit you can make by this way. I am guide to you at this level. This circuit you can also be made by yourself. If you have and during the making of the circuit and at the end, starting, ending, during any kind of stage, you can feel free to ask if you have any kind of query to making the circuit. Now I am discussing the circuit that these are the differential output that you got at the voltmeter, and these are the supplies of DC supply of source 1 and source 2. Source 1 supplied to the Q1 and source 2 supplied to the Q2 of the MOSFET transistors. These sources are combined with the negative VSS. That means the supply of negative with the 1K of resistance. These are also the drain resistance 1 kilo ohm, 1 kilo ohm. Output can be extracted at this level. The VDD is positive supply you can connect here in 10 volts, that is mentioned in the procedure, and you got the voltages of observation column reading. This simulation reading you can got by yourself, and by the making the circuit. Up till now you are able to make simulation. There are 9 simulations which can I provided to you in the same scenario. Most of the people are no, and many of the students can email me their task as well on the multisim. So it is requested with you to make each and every task by yourself and simulate it on your personal PC. What are the comes to the question answers session. After the observation column fulfillment comes to the lab exercise task. What are the conditions of differential amplifier to work? On which condition it works differential amplifier? These questions of the answer and topics already incorporated in the previous sessions on which differential amplifier work on the 3 mod, single mod, differential mod and common mod, and you can write these things in detail at this answer. Give 2 reasons why differential pairs are better than single-ended amplifier. There are 2 reasons you should have to mention here single-ended amplifier, why differential pair can be used here. What are CMRR, common mode rejection ratio? I already incorporated here, and the formula in decimal formula I already discussed with you. How can we improve it with the current source in place of RS? If we place RS, it can be improved CMRR or not. So you have to answer this question at this level. What is the advantage of differential amplifier in integrated circuit? What are the advantages? I already tell you about these advantages of differential amplifier in different aspects. So up till now, any student have any kind of query in this topic, please feel free to discuss. I will elaborate and answer your kind of queries, questions at this level. Uh, Chakar Khan, Muhammad Raza, and Shah Faisal with us. Students, if you have any kind of query, please feel free to ask. I will answer your questions. No questions, sir. Okay. There is no question from student side. So learning outcomes are here. After completing this lab, student would be able to understand the working of metal oxide differential amplifier pair resistive load, and understand and observe the basic feature of metal oxide semiconductor differential pair, how they respond to common mode differential inputs and imperfections they exhibit. Compare the differential amplifier with the single-ended ones. Same scenario that there are 3 modes on which the differential amplifier can be worked: single mode, differential mode, and common mode. We already discussed these 3 things in this lab, and this is the answer of this question number 1. Okay, observation column you can fill by yourself, and this is your task to make this circuit and got the reading by yourself. So up till now there are 9 simulation which I have done in multisim and provided to you. So now it's your responsibility to make this simulation circuit and make by yourself, so that you will be able to make more circuits and clear your concepts. Up till now, if you have not any kind of query, so we end today's lab. Uh, Hope you also meet and raise the question in next lab. Allah Hafiz.